General mechanism of nucleophilic addition reaction of carbonyl compounds. In carbonyl compounds, the C double bond O bond is polar. Carbonyl compounds are polar in nature. Why? Oxygen is more electronegative than compared to carbon. So, carbonyl group is polar due to greater electronegativity of oxygen compared to carbon. So, what happens? The pi electrons will move from carbon to oxygen. Transfer of pi electrons, complete transfer of pi electrons takes place from carbon to oxygen. So carbon gets positive charge and oxygen gets negative charge. So this positively charged carbon atom now reacts with a nucleophile. Now let us see the mechanism of the reaction. So the reaction takes place in two steps. In the first step, I am taking a ketone and explaining here. If you take a ketone and this ketone reacts with nucleophile. So what happens? The pi electrons will move from carbon towards oxygen. So what will I get here? R, C, R, O minus and nucleophile. So this is an intermediate obtained here. The intermediate here is a tetrahedral alkoxide ion. Tetrahedral alkoxide ion. So if you see, the hybridization of carbon in carbonyl compounds is sp2. So the sp2 hybridized carbon atom is now giving a tetrahedral intermediate, means an sp3 hybridized intermediate. So carbonyl group react with nucleophile and it form a tetrahedral alkoxide ion. Alkoxide ion as intermediate. And this step is the slowest step. Always we know the slowest step is the rate determining step. So this step is rate determining step. Now if you see step 2, in step 2 what happens? The intermediate that is formed picks up a proton either from the solvent or from the reagent to give electrically neutral additional product. So the intermediate, what is the intermediate obtained here? Alkoxide ion. The alkoxide ion which is formed as intermediate in the first step will pick proton, where it will pick from either from the solvent or from the reagent to form the final additional product. So this is the final additional product we are getting. This is nucleophilic addition reaction mechanism of carbonyl